I would like to kick us off. So thank you for joining today's session. We will be covering what we believe to be one of the most pressing topics within modern warfare as we see it today, and that is the urgent need to develop autonomous systems and how the industry needs to switch to a software-centric approach in terms of developing these systems so that we can stay ahead of our adversaries in this regard. You'll be hearing from Tristan Rizzi, who's a 26-year veteran of the Navy SEALs, on the challenges that the Department of Defense and operators on the ground are currently facing today as it relates to autonomy. And then from Lyle Johnson at Apex AI on how these challenges can be addressed, and a little bit more about our products and technology at Apex AI. By way of introduction, my name is Paul Balchunas. I am head of corporate strategy at Apex AI. I lead all of our defense-related go-to-market initiatives. I've been with the company for about 4 years now, and I've known the founders for over 10. My background is 20 plus years in the automotive industry. I began my career working in investment banking, providing client services regarding M&A and debt and equity fundraising. I've raised over $40 billion in capital for my clients, and I've been part of a number of landmark transactions within the automotive sector, including the IPO of General Motors, the IPO of Tesla, and the sale of Chrysler to Fiat when they came out of bankruptcy. I was also part of the team that raised over $1 billion for companies that I've been working at as kind of the lead principal for fundraising. Before I turn it over, just one administrative item. You will see in the Zoom below that there is a button to submit questions. We would encourage participants to submit questions during the webinar, and any question that is not addressed during the presentation we'll cover at the end during the Q&A session. And with that, I will turn it over to Tristan.
Hello, everyone, and thank you for the introduction, Paul. So just by way of who I am and what I've done, I am a 26-year Navy SEAL captain. I have 9 combat deployments with several years combined time overseas. My field of expertise is more specifically on the maritime technologies, but it involves all the different support systems that use those capabilities. I, at the end of my career, led the program analysis and evaluations division. I was directly responsible to the commander for managing his $67 billion budget that supported 78,000 personnel that were operating, specifically managing the technologies that were in there. Prior to that, I was a hand select to lead Naval Special Warfare surface program. So the boats that you see over there on the left side of your screen, I developed those platforms. They are, in fact, stealth platforms. And as an operator, mission success equaled lives. That middle boat right there was close enough to enemy territory many, many times that any type of failure in any kind of the onboard systems, support systems, or intelligence systems would essentially have meant the death of the combatant. So when I look at these types of capabilities we're talking about, I look at them from the no fail. There is no failure. We have to do better. We have to do smarter. So as we look to the right side, and I am a defense acquisition graduate, university graduate level 2. For me, it was, we can't buy hardware-defined systems. We have to start moving to software-defined systems with capabilities that adapt as the mission and as the operations do. Working in real time, breaking through the silos, which we'll talk about in the next slide, was critical to operating independently, autonomously, or mixed. Ultimately, what we need is a more efficient and effective data fusion and management process. Next slide, please. So these are some of the precursors, sort of some of the descriptors of what you see. Command, control, and communications with autonomous systems. Sure, individual units can communicate, whether it's airborne to ground, seaborne to ground, ground to ground. But as you can see in the picture on the left, some of these situations become very dynamic. And when you start dealing with HF, VHF, UHF, mobile ad hoc networks, it starts to get very complicated. And DoD is working and has that. But as you move to the right side of the screen, you can see where in a cross-domain environment where you have manned systems and unmanned systems crossing battle zones with restricted fire zones and no enter zones, it becomes extremely complex. And the mission commanders that are usually here in the US, they need a lot of information and a reliance on capabilities to ensure that manned and unmanned systems and fusions or versions therein have the ability to operate in the combat zone effectively. Middleware is the critical function where information is validated, it is crossed, it is ratified, and is put together and fused into a system that allows a mission commander to look and see what's happening in real time to make decisions that affect operational units in the field. Life and death becomes critical. And again, I'll just point to the picture on the right where you have autonomous systems, you've got aircraft systems, you've got undersea systems that are operating independently and together. And that green circle in the middle is actually a mobile ad hoc network where edge computing becomes even more critical. And as we start looking at middleware, the Apex AI solution becomes critical and the only way moving forward. With that, I will turn it over to you, Lyle.
Fantastic. Thank you, Tristan. Hello, everybody. My name is Lyle Johnson. I'm a customer solutions architect here at Apex AI. I've been here for just over 6 years, so I've had a few different roles and know our tech pretty well inside and out. I've been working in robotics and autonomous vehicles for about 10 years now. What I'm going to talk to you today is about the value that our technology brings and how we're trying to address a lot of those shortcomings that Tristan just mentioned. So the technology that I'm going to talk to you about is optimized and designed for edge computing. What we're doing is allowing you to create software and AI models that can run in real time and on military hardware. For any of you that have built a prototype system, you probably know that the first 80% is relatively trivial, especially compared to the last 20%. So that is really where we focus, is getting prototypes into production and solving that last 20% with respect to being production ready. Our solutions are made to be completely future-proof by avoiding vendor lock-in, and we do this by having an open architecture, and I'll show you this through some images below. So if you're looking to build MOSA-compliant solutions that can grow their capabilities over time and be upgraded iteratively, then you absolutely want to look towards a solution that has an open architecture like our technology does. You can also lower the cost of these very large programs by having more scalable and reusable software. So by having proper decoupling of hardware from software, you can reuse more software from project to project or program to program. We'll also show how our solutions are made to integrate directly with JADC2 type systems and the MOSA systems, as I mentioned, and how you can elevate any existing or legacy system to a modern architecture and really get to the point where you're deploying production and mission critical code very, very quickly. If you're already using ROS, the robot operating system, ROS-M, or any of the variants, we also have a very quick path to production for you as well. This is a quick overview of the products and services that we offer. If you'd like a deeper dive into these, we actually have another webinar that we posted a few weeks ago. So you can get more general information about the company background and a little bit more detail about these products in that call. Whereas today, we're going to focus on the defense applications. So the first product that we have is Apex Grace. This is an application runtime framework, or an SDK. It's made to be extremely developer friendly. It's used by software engineers. It provides this abstraction from the hardware and the rest of the system that allows you to write safe, real-time, and certifiable code that gets deployed onto these edge devices, like the combat systems that we'll see today. The second product is Apex IDA. This is a communication framework middleware. So this is responsible for moving the data between the different components within one system and between the different systems that Tristan mentioned a moment ago. So using Apex Grace and Apex IDA together, we call this Apex OS because, they're just bundled together. Many of our customers are using both of them together. And so for simplicity, we call this Apex OS. However, they are designed to be used independently of each other as well. what I was trying to get to is that we've also combined Apex OS for a specific purpose. So for solving verification and validation, or V&V, for these software-defined systems. What this comes with is a lot of tooling, and especially some deterministic record and replay tooling that allows you to test and validate your software much quicker and automate a ton of that work. And then lastly, we have Apex Allen, which is a services-based a solution that we offer. And this is where we can help you set up your ideal development environment and CI/CD system. And this is an ideal starting point for any folks that are looking to port from one system to another, or migrate from a prototype into a production system. Great. This here is just a visual overview of the 4 products and services that we offer. So you can see Apex OS is sitting right on top of the operating system, and the OS is sitting on top of the hardware. As we're trying to depict here, what we offer is you to have a freedom of choice of the real-time operating system and the SoC, or the compute hardware that you're running on. This allows your software up top, like in these different defense domains, to evolve independent of the operating system and the hardware below. This is a big part of what it means to be moving to a software-defined system. You're not making software design and implementation decisions based on the available hardware today. Rather, you want to design your software based on their requirements and the capabilities of not just today's hardware, but future hardware as well. So using Apex Grace and Apex IDA allows you to create safe and secure AI that can be deployed onto real-time military hardware, and implement ISR systems or autonomy systems for real-time data sharing and decision-making. As I mentioned, the scalable architecture really allows you to reuse more of your software components from project to project, or across 2 different defense domains like we're showing up top. There is a lot of common software in an autonomy system that you would use on a UGV, as you would use in even a UAV. There are a fair amount of similarities there. Yeah, full stop. Apex OS is extremely interoperable. We are purposely not trying to build a full stack ourselves. So we think that's a bit of a folly. And so we're focused very specifically on the communication framework and the application runtime framework that enables safe and secure software development. So again, Apex OS here is sitting right on top of the operating system. Just above that, you can see how you can create or integrate with existing JADC2 solutions and create MOSA compliant architectures. Our vision is that any primes or subs for a prime would have their own ecosystem of solutions built on top of Apex OS, or using the ROS ecosystem that you can see on the right-hand side. So Apex OS is completely interoperable with ROS, and on the wire, you can have any 2 ROS systems, any ROS system communicating with Apex OS. And for ROS 2 based systems, you can actually run them side by side on the same computer as Apex OS software. Because we have this connection, this interoperability with ROS, you really can deploy much faster. So if you have existing systems, we have this really clean migration path from whatever you're using today to Apex Grace. We can kind of split this into 2 major phases. There's the pre-development phase, and then there's the series development phase for when you're going into production or mass production. This is the path that we see to be able to elevate any existing system into a modern architecture that is a lot more future-proof, and also safe and certifiable. So if you're in the pre-production phase and you're using ROS 1 today, you would be able to connect this with Apex Grace using a ROS 1 bridge, which just connects via the network. Any existing ROS 2 nodes or ROS M nodes would actually be able to work directly with Apex Grace. And from here, your applications are automatically becoming more robust and reliable because of the APIs we provide within Apex Grace. And I'll show those in just a moment. When you move into the production phase, you would basically cease using all of your legacy APIs, whether that's ROS or some proprietary framework, and you would exclusively use these Apex Grace APIs, which our Apex AI, we've gone through the certification process and ensured that these are functionally safe and can be part of a certified system. All right, so to summarize for Apex Grace, it is a mission-critical software development framework. It really is the glue layer that facilitates building MOSA compliant or JADC2 solutions and deploying them into the same robotic systems or even driver assist systems. They are completely, Apex Grace is completely built to work in these mission critical and production environments, and it really allows you to build a system of systems because of the different abstraction layers and because of the ability for a subsystem to communicate with other subsystems. We're not going to go into a lot of details on the left in terms of what these gray boxes are, but I will say these are the different APIs that exist within Apex Grace. So if you're a software engineer looking to develop an algorithm to deploy into one of these defense domains that you see up top, you would actually be using the APIs from these different feature groups to be able to create those algorithms. Then a lot of these components on the right, like in the analysis, the management, and the safety and security, those are used by system architects and software engineers alike to create safe software layers, essentially. You can create a safety monitor to ensure that a given application is publishing data at the correct frequency and to alert the rest of the system when that doesn't happen. And then you can have things like an event system that is watching for these bad events and deciding when it is too unsafe to continue operations. So all of this can be defined programmatically using the Apex Grace APIs and allow you to develop these ISR solutions that are very, very robust and certifiable. Last thing I'll mention here is that we have certified Apex Grace and Apex IDA according to ISO 26262. So that's a functional safety standard in the automotive world. It's very equivalent or compatible to IEC 61508 to the highest safety level. Full stop there. Next, I want to talk more about Apex IDA. So this is a cross-domain and very high-performance communication middleware. As we're trying to show on the image on the left here, we have a sample UAV. This UAV is going to have at least 5 different internal software domains. There's the mobility domain, there's the chassis domain, you have your full autonomy stack. In the future, you probably also want remote software update module. All of these domains within the UAV have a lot of internal communication. Some of these domains, like the autonomy stack, need to talk directly to the chassis. So Apex IDA is meant to handle all of these types of communication. In addition to this one UAV talking to any of these other defense systems that are deployed in the field, near it, relatively near it. So Apex IDA is responsible for handling all of that data. And it needs to be extremely flexible and not introduce too much overhead. What I mean by that is, if the autonomy stack is designed to use 3 different protocols, but not every part of the autonomy stack needs all 3 kinds of communication, you don't want a lot of overhead introduced when it's not necessary. So these are a lot of the design decisions that went into making Apex IDA very flexible while maintaining extremely high performance. So we can extend Apex IDA to support any proprietary sensors and any bespoke communication protocols that are associated with those sensors or hardware devices. And we can trivially add this as a supported communication channel. To give you one example, if I'm a software engineer and I need to make a dashboard for some operators in the field, if I'm using Apex IDA, this is extremely trivial. I can basically just say, okay, I want to look at this UGV. I want to understand its current operational status, maybe its fuel load, and the number of occupants. I want to make a dashboard with this information, and I want to combine that also with the information from some local drones that are flying in the area that are potentially identifying hazards. If I were using Apex IDA, I would simply be able to just subscribe to the data channels that I care about, and I don't have to worry about, excuse me, what communication protocol is the drone using, what communication protocols, multiple, are being used on the UGV. Apex IDA handles all of that data translation so that you can just say, I need this data here and with these guarantees, and the middleware will handle the rest for you. Great, so I've mentioned a few times, but Apex IDA is designed to be extremely low latency and consume very few CPU resources as possible. That leaves more compute resources for your applications and the different algorithms that are running for the different defense domains up top. It's really hard to characterize middleware performance without an exact use case. So I tried to provide a specific example here. Pardon me while I read off my notes. We did some, we have a reference system based on an NVIDIA Drive AGX Orin running with the QNX real-time operating system version 7.1. We're able to run 17 nodes with 47 different node instances, which is transferring up to 42 gigabits per second of data over 46 publishers, which equates to about 1,800 data transfers per second. And that equates to only using 2.3% of the overall CPU of that Drive AGX Orin. So that's what I mean by being extremely high performance, offering very low latency, nanosecond level latency, in fact, and moving huge amounts of data through these systems. That plus you're able to connect multiple systems to each other and share data between them.
And Lyle, just to add to that, this is also one way that we're able to reduce cost for our customers is just because of the efficiency over on the CPU usage. So as these systems become more and more complex and more data is being gone through them, it's critical to keep the cost element in mind as well too, and making sure that we are as efficient as possible with the CPUs that are in the system already.
Yeah, exactly. If we're consuming very little CPU resources, again, there's more for you to use. Therefore, you don't need as many computers in the system, in the vehicle. You need fewer, less wiring between them. It just reduces complexity down so much when you move to these software-defined systems that can run on larger hardware. And again, when we're consuming less of it, you get more. So Apex IDA has to move tons and tons of data, but it also needs to do this in a secure way. So, we do integrate with we have many different layers of security, and we'll utilize any built-in security for a given communication protocol. And I'll show that on the next slide. Yeah, the last thing I want to mention is that Apex IDA, the design of Apex IDA is actually what gives us this abstraction or the decoupling of hardware from software. It's because Apex IDA abstracts away the OS and all the hardware beneath it that we can evolve the sensors that are bringing data into the system, as well as the compute hardware below it. So it's an extremely valuable part of designing a software-defined system, is having this decoupling and avoiding the vendor lock of these lower layers, and especially the hardware. Great. So just a few points on security. So Apex IDA has APIs that that developers can use to add additional layers of security, but data coming into the system can also be secured. So, for example, DDS is a specification that comes with a security standard. That's not the exact phrasing, but within the DDS specification, there is certain security modules defined. That's a more accurate way of saying it. Apex IDA will natively accept, let's say, these encrypted data streams and be able to safely store keys and use any onboard, hardware security modules that are available. If it's available through the kernel, then it's available to Apex IDA. So regardless of which communication protocol you're using, if it is able, or if it comes with security, we absolutely encourage and absolutely support this as well. Yeah, full stop there. All right, that was the last slide for Apex IDA. So next we're going to shift slightly to Apex Allen. So this is the engineering services that I mentioned before. If you have an existing program and you feel like you're not able to deploy code fast enough, or your developers are saying that they're not getting feedback about how good or bad their software is doing in the field, then this is very important for you. What we've been doing with our customers in the last few years is advising them on how to create their ideal development environment and a modern state-of-the-art CI/CD system, continuous integration, continuous development system. The whole idea is that you can create this loop from your developer or your V&V engineer or your suppliers and partners as they introduce code changes or any change to your system. You want to be able to test those changes, obviously. You want to be able to test them automatically wherever it's possible. And you want to see those changes on the road and understand their effects on the overall system. So that is exactly what Apex Allen is doing. We have, of course, a broad set of tools and a very extensive development environment in-house, which is a collection of proprietary and open source tools, but all put together to automate this whole process. 95+% of this development process needs to be automated, and if it's not, then there are bigger issues at play, and we can absolutely help with that. The whole goal is to make sure that your developers, your architects, and your system integrators are getting the feedback time within a few hours, never more than a day. And that is the whole goal here. Next, we have Apex OS for verification and validation. So we talked a lot about Apex Grace and Apex IDA. They have a ton of different capabilities, not just for developing an autonomy system, but they actually solve many different parts of a software-defined platform or a software-defined vehicle. Here, we're showing how you can use Apex OS specifically for verification and validation of your software. So whether you've created software using Apex Grace or you have your own proprietary software, but you still want to take it through a V&V cycle, that's exactly what we've put together here. So Apex OS for V&V is solving the challenge of reducing the effort that it takes to validate these large systems. As these systems become more and more software defined, they become harder to test, especially integration tests, system tests, and acceptance tests. The best way that we've seen to combat this is using real world data. So our kind of flagship product for Apex OS for V&V is this concept of deterministic record and replay. It allows you to record data on your test vehicles or even production vehicles, and allows your developers to play back that data on their developer system in a fixed order. This allows you to have deterministic integration tests, which means that you can have a lot higher certainty that when a test passes or fails, that this is the actual real world result. It's too easy to write a test, a generic test that's not using data from the real world or even synthetic data that doesn't fail when it should or passes when it shouldn't. And so using this real world data is a huge step up in this process. We also have a lot of other features within Apex OS for V&V that allow you to test your software and test it at scale, including trace data analysis that allows you to understand how data moves through the system between different processes and where the hotspots are in that code path. So not just debugging one single process, but debugging an entire system and understanding exactly where a fault comes from. Fantastic. So just to wrap up on my part here, so I hope I've shown how we've really tried to solve bridging communication between autonomous systems and manned systems, as well as command and control, and how true system fusion is not something that really one company can solve, and that we're trying to take a huge bite out of that pie to enable you to work on the interesting functions that are going to help our personnel in the field and really enable these combat systems to get to the point where the DoD and others have been saying that we need to be at. Great. Paul, with that, I'll hand it back to you.
Thanks, Lyle. Wanted to spend a minute talking about some of the successes that we've had in selling our products. When we take a step back, defense is a very important initiative for us at Apex AI, but we want to make sure that we have a commercially viable product as well in multiple industries. Listed on this page are a couple of those examples in autonomous vehicles for civilian use, off-road autonomous tractors, medical devices, and autonomous vessels. I would like to note just two of these examples here specifically that we've announced. So one of them is Moya, which is a company that sits within VW. And we are the middleware system on their ID Buzz. And this is a cross-domain system that requires safety certification and safety functionality and real-time determinism. So a very complicated system, something that we're very proud to be part of, obviously with such a large and well-known brand such as Volkswagen. Similarly, with Brunswick on the autonomous vessels, we are the middleware provider on their auto docking feature, which was announced about a year and a half ago, 2 years ago. This again is a system that allows the operator of the boat to push a button and the boat will simply dock itself with your hands off the steering wheel. Again, Brunswick is a major player in the passenger vehicle or in the marine personal space, and they have many brands that are used. And again, another company that we're very close to. With that, I would like to say thank you for your time. That concludes this portion of the presentation, but we would like to open it up for Q&A, and I see that a couple questions have already been asked. So maybe we can start there, and I can hand them out to you, Lyle, or
Great.
Tristan, as we need. So first question, as a developer, how does the foundation of your solutions on ROS2 provide advantages over proprietary solutions working directly with ROS2? Maybe Lyle, you can take that one.
Sorry, what was the meat of it again? I missed just the first time.
Yep. As a developer, how does the foundation of your solutions on ROS2 provide advantages over proprietary solutions that are working with ROS2?
Sure. I mean, the main thing is how much software do you want to maintain, or how much software does your company want to pay to maintain? That's one of the big differences, I would say. I mean, sorry, let me back up. We do have a fork of ROS2. What we've done is we've maintained the APIs up top so that it's easy to port from a vanilla ROS2 or open source ROS2 program to being an Apex Grace based program. But we've completely changed the implementation of the APIs underneath. So the behavior of our APIs will be different compared to ROS2, and different in terms of honoring real-time execution, being deterministic, and in general, being more robust and more reliable. So whereas, yes, you absolutely could do this in-house yourself, it is more about where do you want to focus your efforts. So many of our customers, all of them, have chosen that, hey, we don't want to maintain this base software layer. We want to focus on the differentiating and interesting parts of the stack. So maybe, yeah, I would hold it there, but happy to take a follow-up and go deeper.
And I can add that from a company perspective, using ROS2 in automotive as an example, that's never gone into production. So it's not out there on the road. However, if you were to use Apex AI and its ROS2, the software we developed, you would be able to take it into production. So you're saving time not having to rewrite the code, but it's also cheaper because you're able to do it much faster as well. So that is a big advantage of using us versus doing it in-house yourself. The other point that I would add is most companies today are not set up internally or structured internally for agile software development. So a lot of the engineers are sitting within specific domains or silos, and they're not speaking with each other. And that makes it very challenging to develop complicated software code, especially when you think about more hardware being added into these platforms. So it's critical that that all of the teams are working together, and you're not just trying to integrate it and slam it together at the end of the V cycle and figure out what problems that you have.
Yeah.
Next question, how do you support safety assessments against MIL spec or MIL standard 882E? Maybe Lyle, you can take that one as well.
Sure. Yeah, because we've gone through the ISO 26262 functional safety certification process, and we've basically assessed the differences there. One of the big differences is with 882E, you're evaluating the entire system, whereas with functional safety standard, you can certify specific components as a safety element out of context. And then when you build the final vehicle, that is in context, right? So to support 882E, we are in general going to be involved in the certification process. So our safety team would consult yours on how to effectively deploy our software and how to verify and validate that it is behaving as expected in the overall system. So it's certainly not something that we just push across the desk and expect you to do yourself. Maybe you would prefer that, but in general, that's just not really how safety is done on such large, complex systems. So again, we would be involved to at least consult your safety team on how to best integrate and leverage our safety manual, our safety artifacts.
And I would add that from a BD perspective, when we started our defense initiatives, this standard was really why we received a number of inbounds, because we had the ISO 26262 ASIL D certification, which is incredibly difficult to get. And the fact that we have that was interesting for a number of the primes and other new tech players in the industry, because they recognize that 882E is something that's going to be important to them as they're developing these technologies. And that's where we've gotten a lot of traction, given that we've gone through that process on the automotive side before. The last question in here, again, Lyle, for you. What programming languages are supported, and how do we deal with legacy code or libs?
Sure. Developers today are using C++17 for all of the application development. You can use Python for prototyping, even within Apex Grace, but to certify the applications you develop using Apex Grace, by the end of the day, they would be just the C++17 APIs. So it is modern, at least for safety critical robotic standards. C++17 is modern. Within the next 18 months, I'd expect we're supporting C++20. We're also looking into Rust for the future, for future versions, PLVs of our product. But yeah, today it is C++. And what was the second part of the question? Dealing with legacy code?
Yep, deal with legacy code or libs.
Yeah, so typically you would stand up your existing system with your next gen Apex OS system side by side and connect them over Ethernet so that they can communicate. And then you would take a very iterative approach to porting your code. So at the beginning of the project, you'd likely sit down with our application engineers or someone like myself, and we would identify, okay, what are all of the third-party libraries that you're using? What are their equivalents within Apex Grace? And identify any gaps. But in 95% of the time, you're able to go from whatever libraries you're using directly to using Apex Grace. And in some cases, you'll still have some third-party libraries, but we'll have a path for you to eventually get rid of those third-party libraries like Boost, for example. That's probably one you're using, and introduce something that can be memory static at runtime and honor real-time execution. So yeah, not one answer, but if you told me the third-party library, I could definitely tell you the path forward.
Next question from Christian for you, Lyle, is does Apex IDA DDS as a communication system, or does Apex IDA use DDS as a communication system?
It supports DDS. Internally, Apex IDA is built purely on zero copy based shared memory. And then if any external communication from one computer to another needs to happen, then it would load basically the desired connector is what we call it, and use the protocol that's defined by you, the developer. So if you wanted to connect your system over DDS, then you would basically you would just have to configure this through your configuration file. The code that you write doesn't actually have to change based on the communication path that the data will go through. You can do that purely by changing a configuration file and saying, hey, this data type or this data channel, should be going through the DDS system or through MQTT to go into some IoT device, something like that. And then Apex IDA handles all of the data model translation between one protocol type to another.
Next question, can you elaborate on cost savings potentials and scenarios, ROS2 hardening versus Apex AI? Let me kick off. I'll start the first part of this by talking about the cost savings, and Lyle, maybe you can talk about scenarios of
Mhm.
ROS 2 hardening versus Apex AI. So on the cost saving side, as you think about development, I'm going to use an example from our CEO's time while he was at Audi. He was developing an ADAS feature, left turn assist, to monitor for oncoming traffic. That was something that he worked on at the prototype phase. And by the time it got to market, it was almost 8, 9 years later from when they initially started working on it. So the innovation cycle was incredibly long. And one of the reasons for that is developers are using software that they write in the POC phase. And once it goes to the R&D teams for pre-production, they take all of that code, throw it out, and basically rewrite it during the pre-production phase or the pre-development phase. And then once it goes into production, that code is rewritten again so that it's up to automotive standards, as an example. However, using Apex AI, you can use that same code throughout all 3 phases of this process, and that reduces the time. So as opposed to maybe 8 years, you can get it down to 2 or 3 years. And it saves additional costs from a time perspective, but a developer perspective. Just to give an example, we've had customers outside of automotive reach out to us. We spoke to them, worked with them for about 6 to 8 months in terms of a POC, went into pre-development, and now we're going to be going into market. And that all happened within about 2.5, 3 years. So we were able to shorten that time significantly. Maybe you could talk about the second part, the hardening of ROS or Apex AI versus ROS too, Lau?
Yeah. The other thing that I was going to mention was with respect to cost savings is being able to reuse your code. What's the best image for this? I guess this would be so. Across many of these different defense systems, you're going to have a lot of base software, and not just the middleware and SDK that I'm talking about, but even within the autonomy stack, the perception systems are going to have a lot of commonalities. Now, of course, a tracking system for a ground vehicle versus aircraft is going to be very different because they're moving at different speeds. But there is still a lot of base software that is shared among these different robotic systems or even semi-autonomous systems. When you have an architecture that decouples the software from the hardware, you can take this code from system A and go use it in system D, right? That is saving you a ton of time. And when you have enough of these components that you can pick and place and put them together into different systems, you can eventually I lost my train of thought on that one. Sorry, we're gonna have to disregard that. But there is a lot of commonalities between these systems. There's a lot of software that you can design to be generic enough to be used in more than just one kind of robotic system. So having the right architecture and having something that is flexible enough to be deployed in different scenarios is absolutely going to save you a lot of time and money. Did I miss any part of the question?
Nope, that covers it.
Great.
2 left here. Lyle, when you presented Apex Allen, you said that true system fusion is nothing a single company can do. Are you cooperating with any engineering services companies? And in general, are the opportunities to work with Apex AI?
So we certainly have in other industries, so speaking of automotive and agriculture, for example, in general, yes, we're open to this, and our technology is designed to do this exactly. Whenever you have more than one supplier or team working on the same solution, the most important thing is that you have a common development environment and a common CI/CD system. So as long as we have this, then absolutely, the more people at the party, the better. Contrary to the way systems used to be built, where more people meant moving slower.
And then the last question in the queue, you mentioned an open architecture. How open are your libraries?
Yeah, so they are, we like to treat ROS 2 as an open standard, right? So in quite a few industries, they do things what we would consider backwards. They basically, a bunch of companies, they meet, they put together a specification, and then later they build something to match that specification. We see ROS as doing things the opposite way. First, you write code, you do this in the open, and as you reach a critical mass of people using this, it essentially becomes an open standard. So whereas the implementation of the APIs I'm showing on the screen now, most of them are proprietary. Like we haven't open sourced them. You couldn't find them on GitHub or GitLab, for example. We do offer source code to our customers to allow them to troubleshoot and understand their systems more clearly. But yeah, as of today, it is a closed source proprietary stack. You know, in 5-10 years, it's possible that it could be completely open source, but today it is not.
Okay. Thank you, Lyle. Are there any more questions that the audience would like to have addressed? Just give it a couple seconds here, see if there's anything else that comes up. Okay. So with that, I would like to thank you again for your time today. Very much appreciate you joining. Hopefully, you found this presentation helpful and insightful, and have a better understanding of the capabilities of Apex AI and how we're able to address many of the challenges that we're seeing today in the defense sector. We would very much welcome the opportunity to work with you and your companies, and we would encourage you to reach out to Lyle or myself. You can see our email addresses here. And you could also find our contact details on the company website at apex.ai. Thank you again, and looking forward to speaking to you in the future.
Thank you all.